Well, this isn't a class about using Blender or Photoshop. These tools are incredible, no doubt, but someone had to write them. This is the class where you become that person. You won't just use tools like these, you'll actually build them. So computer graphics is all about converting a high-level scene description into a flat 2D image. That's basically the essence of computer graphics. Here's the whole idea behind a photorealistic image. For every pixel, you shoot a ray, which is basically a vector. You see what it hits, and you figure out the color. And this is what these 4 lines can do. The rest of the course is just learning how to do the last step really beautiful. So here's another example of what that loop that we just saw can do. We shoot rays into the scene, and we see what it hits, and we compute the color, and then we draw that on the image, and that's pretty much it. Of course, there's a lot going on under the hood, but that's the main gist of it. But now here's an interesting question. Why can't AI do all of that? Remember, we just saw this diagram in which we talked about that computer graphics is all about providing a scene description and it converts that into an image. But that is exactly what an AI model would do. You give it a text prompt and it spits out a 2D image. So why would we even consider learning graphics? Well, it appears that there are a couple of problems. So for example, you give this prompt to an AI model, which is supposed to spit out an image. In this, you'll be highly specific. You say that you want an 8-foot tall door and you want 18 flowers with hexagonal formation. And there's a cat that's sitting exactly 5 meters from the house. And then there are 3 trees which are also 5 meters from the house, to the left of the house. So that's what you need to do. And lo and behold, the AI gives us an output. This is a really nice looking image, but there are a lot of serious problems with it. First of all, the number of flowers, that's wrong. We asked 18, it gave us 17. And the cat, it basically looks like really farther away than 5 meters. And the trees are closer, even though I asked specifically both of these items, cat and the trees, both exactly to be 5 meters from the tree, the house, and that's not the case here. And I give exactly the same prompt again, and it generated a completely different image. On the surface, it may look similar, but the trees behind the house, they're completely different. The foliage is different, lighting is different, even the camera angle is different. So you can see that. So in this case, if you generate images by using AI, they'll be completely useless if you want to do something useful, like creating an animation or a simulation, for example, because one image is completely different from the other, and you have absolutely no way of controlling that, at least yet. So AI models, they are not precise, they are not deterministic, but the graphics is super precise and really, really deterministic. You can generate millions of frames, and you have absolute control over every single frame and every single model and graphics, and you can control every single pixel in this image. And this is how much control that you have when you're doing computer graphics techniques, which is completely impossible with AI, at least now. Things are changing fast, but let's see. It appears that it's going to take a little while when the AI catches up to the graphics. So to get anything useful, basically you need to create a foundation based on the computer graphics techniques, and then you apply a very thin layer of AI and machine learning, which acts as a makeover on the foundation, and then that's the final result you get. And let me show you an example. So this is an example of a really famous game called GTA. In the bottom left corner, you see the actual game footage, which is generated using the graphics techniques. And then on every single image, you apply AI techniques, and then this is the final result you get. Obviously, on the surface, the difference is massive, but AI cannot simply generate animations and interactive software or games on its own. It has to stand on some solid foundation, and that solid foundation comes from computer graphics. What do you actually build during the semester? Well, here's a highlight of selected artifacts that we'll create every week. These cover a wide variety of techniques that we'll use to create these images. So none of these images are a result of AI. Everything was created purely from scratch. These are basically mathematical equations becoming really beautiful artwork. All right, the math, sure, the elephant in the room. Let's address that. There is linear algebra in there, sure, we don't deny that, but we'll do the math from the ground up during the semester. You don't have to worry about it. Computer graphics is one of the best applications of linear algebra because here you actually see it. A matrix isn't a grid of numbers anymore. It's this rotating right in front of you, and we'll learn each piece the moment we need it. No wall of theory up front. We'll write all the code in Python, and NumPy is going to do the heavy lifting. And if you haven't taken the linear algebra prerequisite yet, you can just simply shoot me a message and I'll try to grant an exception based on the student performance, of course. So one of the main questions is whether is this course worth registering or not? Well, the skills are there, and these are one of the most highly transferable skills to other disciplines. So for example, in this course we will learn about GPU architecture and GPU programming, a bit of parallel computing. Of course, we are not going to a lot of depth in this case, but you need a little idea of parallel computing in order to do GPU programming. And of course, the math, that's there. So these are the fields that our skills that we do in computer graphics course will be transferable to. For example, you can use a lot of these skills in machine learning, computer vision, robotics, virtual reality, and a lot of other fields. These are just to name a few. So computer graphics is not an isolated course. It's tightly integrated into an ecosystem, and it's a foundation to many other things that we can't immediately see. Computer graphics CS 453 coming in fall 2026. Seats are open right now. Ever wanted to build the cool thing instead of just using it? This is your shot. Enroll this week and grab a friend. You can DM me with any questions at all, and I'll see you in there. Bye bye.